lefts are identical to the right, so that if you have a bilateral patient, you can be guaranteed you can have an exact duplicate of the left and right prosthesis when you finish. The first thing to do is determine the patient's ankle circumference. Of course, we're not really concerned about the calf circumference because, as you know, in prosthetics, 9 times out of 10, the calves are too large in the first place. Plus, the finishing molds are beveled in the back. See the way they taper down in the back, and the idea of that is so that the mold will flare up into the socket and help create an even, smooth, gradual transition from the socket to the finished cover. Now, this patient happens to be an 8 1/4 inch ankle. So we selected an 8 1/4 inch right finishing mold because she's a right BK amputee as well. And the finishing mold gets fitted over the prosthesis. And the most important thing about all this is to view the prosthesis first. Before you go ahead and pour foam material inside the mold, you want to look at the prosthesis and view it for shape. Okay, you're not really concerned with how everything looks just yet, but it should look like a generally normal shape for that particular patient. For example, this is the 8 1/4 inch mold, which is an average height, average build female. Now, if you go to the 8 1/2, this mold was made off a tall, slender male. If you look at the difference, they're very different in shape. Now, if the patient happens to be 8 1/2, but looks like the shape of the 8 1/4, you use the 8 1/2 mold, which is longer and more slender, and then thin down around the ankles. The idea is to minimize your shaping time. So that's the reason why the molds change in shape as they change in circumference. It's not always that you're going to use exactly that ankle circumference for that particular patient. We realize that there are many different shapes and sizes of amputees, but if we were to give you a mold for every single shape, no one would purchase them because you need hundreds of them. So we figured out a way to keep it limited to a group of 14. Okay, so we're going to put the 8 1/2 right away, and we're going to use this 8 1/4 right finishing mold. The first thing we're going to do is, on many prosthetic feet, they have a very sharp proximal edge. Now, the idea is that the foam will now cover the prosthetic foot and hide the transition between the prosthetic foot and the foam cover. We want to turn this into one monolithic unit. So what we're going to do is the expert technician, Dr. Dean, will come over here and bevel the prosthetic foot so that we can get the finishing mold to fit over it. Now he's going to take that into the machine room and bevel it. That's the next step. There you go, sir. Now preparing the finishing molds for an endofoam project. So what Dean has done is clamped the back of the mold and lined up the grooves. There are posterior grooves on the back of the mold. If you line them up, you'll be guaranteed that the inside of the mold will mate up together, so you don't have any rough edges down the posterior side. So after you put a clamp down on the bottom, then you take some clear 2-inch packing tape. Pull it very firmly over the mold and the prosthetic foot. The idea is that you want to pull the mold down as tightly as possible on the prosthetic foot, which will ultimately create a very smooth skive of the foam into the foot. If you tape it down loosely, you're going to have it kind of rough, and you'll have a lot more finishing to do later. I mean, buffing and polishing. And the idea is to do it as little as possible. Now, what Dean has done is clamped a little higher. And now he's going to take the proximal side of the mold down to this prosthetic socket. Again, pull down firmly. Very nice. Very nice. Let's see what you got now.
Tape up the mold.
Okay, now what you have is, this mold is taped down to the socket and the prosthetic foot, and what you really want to do is look it over at this point. Now if you see there's a little bit of a bump in here, that's from the socket itself. Now it looks like a problem, which may be, but what we've actually managed to do was fill in with foam around this rise in the prosthetic socket, so it's actually finishing the foam out, and you'll see the foam at the end sky right into the socket around that area. Okay, now what Dean is going to do is fill in the back, and we're ready to pour this material. Let me put a clamp up higher. Okay. Let's see. Here you go. Now you want to make some kind of tool up so that you can hold the prosthesis down while you're doing this project. You don't want it jumping around while you have all this gloppy, liquidy foam running around. So we made up a little jig there, which you can very easily make in your own facility. Right there is a little wedge that you're going to put into the groove on the finishing mold so that you can hold it open, enabling you to pour the foam in during this process. But one thing you don't want to forget, doctor, is you got to keep a clamp on both ends of that wedge so that you make sure that the mold is not going to shift around on you. Now you have it open, and we're going to mix up, in this case, 200 grams of Endofoam. This is a product that will allow you to make about 40 BKs off a 1-gallon kit of material. Now follow the instructions. Shake well before every application. The nice thing about this material is that you can adjust the density of the foam by adjusting the mixing ratio. For example, if you wanted the foam softer to match a sedentary little old lady, you would mix it at a ratio of 85-15. And if you wanted it firmer to match more of a muscular person, you can mix it at 70-30. So you have a range of mixing ratios. Also, that also proves that you don't have to be exact with the mixing ratio, as you can see.
You said 200, that's screwing me up.
What do you do, 200?
Yep.
Okay, we're molding, we're going to make a total of 200. So that means, and at 75-25. So we're doing 150 of the part B, which stands for big, and 25 and 50 grams of the part A. Now once you have that mixed, you want to have your clamps ready, your mixer ready, everything ready to go, because you're going to be mixing this very well and pouring it into the mold as quickly as possible. The material will not begin to foam up until you stop mixing it. So you want to mix it for about 10 seconds or 15 seconds, or until you do not see any more color swirls in the material. Now, at this point, quickly pour it into the mold, and if you can get it all into the mold, it takes plenty of time for it to rise. The idea is you don't want it to be rising in the cup and have difficulty pouring it into the mold. Now remove the clamp and take some more, the wedge, and take some more of those clamps and clamp the remainder of the finishing mold tight. The idea is that you want to close up this system so that the foam purges out of the system in the weakest area, but you want it to build a little bit of back pressure. Dean, you want to back up so they can see it rising? There you go. And if you allow it to build up a little bit of back pressure, you can minimize the potential for having large air pockets or weak areas in the material. But at this point, you could just about walk away from this project and return in 15 minutes after the Endofoam has set. And you can see it kind of rising. You zoom in on there. See it now? You're going to see it form right around the socket. There it goes. And you'll see, I think there's an air pocket around the ankle yet, right? You'll see it around the ankle filling in too now. Oh, that's nice. And you'll see it purging out of this area, but it's filled in everywhere else. Now, in some cases, the average BK, you could use a total of 200 grams mixed in any mixing ratio you prefer. We like 75-25. We get the most consistent results and a real nice feel to the foam cover. But if you're doing a larger BK prosthesis or using a foot with a hollow foot shell, like a Seattle Light or a Flex foot with a hollow foot shell, you may want to go to 250 or 300 grams total. But mixing it at 200 grams will do the average standard BK with a standard length residual limb. Also, we happen to be molding this foam over our EndoFlex prosthesis. So it's its own mold release. If we ever have to get to the prosthesis, it will peel away from the copolymer. But if you're molding it over a modular system where you want to protect the componentry underneath or be able to access it in the future, before you do the finishing mold, wrap the componentry with some saran wrap or some type of plastic wrap, and then do your foam project, so that if you have to get to it, you just cut right through it, and the saran wrap will create a barrier between the foam and the componentry inside. Now at this point, we're just going to leave this for about 15 minutes and then demold it. Okay, all right, so now we've waited about 15 minutes, and now Dean's going to take the mold off this prosthesis, leaving us with an Endofoam cover. And hopefully we'll have very little shaping to do. So first thing, we reverse the whole process. Remove all the clamps, and then cut the tape away. I want to remind you of one thing. A lot of people using flex feet or spring lights or things with very flat, broad pylons. We've had some experience with these, in using these covers, where they create air pockets of foam in front of the pylon. And the reason why is because when pouring the foam into the mold, if you don't pour the foam past the pylon and into the anterior side of the mold, what happens is the foam lands on the pylon and rises from the pylon back and traps air in front of the pylon. So when using a flex foot or something with a large, broad pylon, the G foot, for example, any of those, try to pour the foam past the pylon into the anterior side of the mold so the foam rises up over the pylon, kind of like a cake rising around it. And that will resolve any of your air problems in front of the prosthesis. Now, he's got all the tape off of it now, and then what you want to do is carefully separate the back tabs of the mold. I'll take that, sir. Look at that. Okay, so Dean is very carefully now just going to peel that away. The foam will not adhere to the polyethylene. These are low-density polyethylene molds which don't stick to anything. And out we come. Now, at this point, you don't want to be squeezing it because the foam is now releasing some gases, and if you compress it now, the foam will not return to its original shape. So you want to you want to avoid squeezing it or handling it for about 2 or 3 minutes after the foam has been after the mold has been removed. But you can look at it now. At this point, we're ready to deliver this to Mrs. Smith or Jones. If you look at this socket, now remember how that socket was protruding in the mold, but what's happened is the foam has actually covered up that rise and tapered in a blend. And the only finishing we're going to have to do is this little bit of trimming in the back and a little bit of skiving around the heel. And this thing, at this point, we can let this woman go home with a foam cover. At this point, we'll just pull a stockinette over it so she can go home with it and it'll have some shape. But for our purposes, since this is an educational manual, we're also going to show you how to do a prosthetic skin. And the next step is to prepare this prosthesis for the skin. Thank you, sir.
Welcome, sir.
See now. So Dean is just blending and tapering in that foam so it makes a nice smooth transition from the foot to the cover. And the back tab, you see that excess material from the back of the mold, that can be trimmed off with a sharp scissor or a scalpel or a razor.